Okay, so in this section, we're going to take a look at solving systems of equations, but we're going to take a look at nonlinear equations, right? Whether one of them is nonlinear or both of them. In this case, what we have here is we have the graph of a line and a parabola. All right, so looking at the graph here, so what does it mean for it to be a solution? All right, now it's the same idea when we're solving in those two variables, the linear equations. Right, it was where the graphs, where the curves intersect. Right, in the previous section, we're just looking at lines, but here we're looking at nonlinear, so other types of curves. In this case, a line and a parabola, right? And the solution would be where these graphs intersect. As we see here, this particular system is going to have two solutions. All right, so we're going to use similar techniques that we used in the previous sections by substitution and elimination, right? So here we're going to find one of these to substitute into the other. I think here, one way we can do this is here, if I bring y over to the other side, I can write this as y equals to 2x squared. Okay. And now we can substitute into the first equation up here, right? So we have 3x, and instead of y, we get negative 2x squared equals to negative 2. And now I have a quadratic, right? So I'm going to set this equal to 0. So I move everything, if I can move everything to the right, I get 0 equals to 2x squared minus 3x minus 2. Now once we're here, we can say, all right, I can solve this using the quadratic formula. Again, that always works, but here I can actually factor this out to solve it much quicker here. Minus 2 plus 1, right? We need opposite signs there. So we get 2x squared minus 4x plus x for that minus 3x in the middle, and then minus 2 at the end. All right, and now we can see we have two values for x, right, that make that 0. Now these are not all of the solution, right? It's just our x coordinates, right? So when x is equal to 1/2, we can plug it into the y equals part. So y equals 2 times negative 1/2 squared, right? So this becomes y. 1/2 squared is 1/4 times 2, gives me 1/2. So here we have our first solution, right? This ordered pair. And then my other one, I plug in 2, we get we get 2 squared is 4 times 2 is 8. So the other solution is the ordered pair 2, 8. Right. And we can see here, right, the substitution method in action. And just to confirm here, we can plug in so negative 0.5. Right, we see that's one of the solutions. The other one was 2, 8. Right. And we see what it means for it to be the solution, right? That it crosses, it is the point of intersection that is on both of those graphs. Okay, so that is how you solve a system of nonlinear system using the substitution method.